Hello and welcome back to my shed. I thought I'd better go over another case study with the Book of Gold, because next week the only copy of the Book of Gold in existence currently will be at Main Tech and with Andrew Cook. So as a reminder, the Main Tech show's next week on Wednesday, Thursday. On the CTC stand, if you go there and put your name down, your details, you will actually get entered into win this book here. So this is our first publication, Enhancing System Reliability through Vibration Technology. I've signed it there, dated it, the Main Tech Show 2022, CTC, JPS Reliability. So yeah, if you go to the stand, you can see that and possibly win it. There will be a copy of that for you to flick through, but that one will be kept nice and pristine for the winner. As mentioned before, we're going to go through a case study today from the Book of Gold, mainly because this particular book will be at Main Tech next week, and then it'll be staying with Andrew Cook. So this is the Book of Gold. This is actually the first ever printed version, written by myself and James Pierce. And what we're going to do today is we're going to go through an EDM case study, and on this one is chapter 9, section 12. With all of our case studies, we have sort of like a background, your findings, and then obviously the vibration data and stripped down images. So in this particular one here, the background was this was a process plant water pump motor. They had a variable speed drive on it for quite a few years, and obviously they didn't notice a change in pitches over the years, but one day they came in and it sounded quite bad. So we were called to do an asset assessment. So we did a vibration assessment and we said clear as day, high risk damage, stage 4, you've got EDM damage from the high frequency switching on the drive going through the bearing. You'll see in the book we have some vibration data as a peak view data. We got the stripped down images, we got the failure mode, EDM damage. There's a bowl there, you can see like the washboard effect, and because there's a roller it's actually longer across, and these are the rolling elements which I was quite impressed with how fatigued they were. And on the second page, or third page sorry, we have another data. This is now showing us the inner race defect, and we have the lovely washboard pattern on the EDM. Now we actually have that bearing here, so what we'll do is I'll just quickly show you the bearing up close. So it's in 2 halves, cut them in half there, so it's a reasonable size bearing. And what was very nice was you can see on here the it's sort of like a mottle, sort of misty colour, obviously as the current passing through, but this had been there for so long that it fatigued, and we got some lovely cracks there on all the elements there. Beautiful fatigue. So this is just age related fatigue. Obviously the driver behind it was EDM discharge through the bearings, so you can see there some lovely defects. We are seeing EDM defects a lot more lately. We'll do a few more videos on other case studies for EDM, but this was quite a simple one. So we went there, did assessment, we could tell what caused the defect, what the defect was, the bearing failure was, and now we're helping them to rectify so this doesn't happen again. And look, there you go, see. While I got you, I'll just go through one thing. I don't know if you know this. So when we're measuring bearing defects, we're sampling to pick up the period of the defect signal, of the signal from the bearing. So we're sampling, and if we sample fast enough, we could pick it up. With most analyzers now, we've got the Peak View Plus, SBM HD enveloping as well. They sample super fast. I'm sure it's like 20, 40 kilohertz. So we're broaching to like the ultrasound range. So the faster we sample, the sooner we'll pick up a defect. And just to get people's heads understanding, where the defects will come from, if we look at this bearing here, I've put a line straight down there. So to work out an inner race defect, it's simple as the period of the defect signal passing the inner race and the rolling elements. So if we look there and we count how many rolling elements this imaginary defect will hit, so we've got 1, 2, 3, 4, and nearly 5. And I wrote down a defect, so this one is actually 4.9 orders. So that is how we pick it up there. Cage, as you would expect, is about 0.4 order. So to prove that, if we look at this mark on the cage, and we see how far that mark on the cage goes around when we move the inner race for one revolution of the shaft. So as we move it around like this, there we are, that's one revolution of the shaft, and our cage is moved there. So like 0.4 orders. If we bring that back together, and we can do the same for the outer race, is for one revolution of the shaft, how many balls pass the imaginary defect on the outer race. So if we go there and we go 1, 2, 3 and a little bit, and the defect frequency for that is 3.04. So that's just a little visualization to help you understand. So when we pick up a bearing signal, it's not like a frequency, but it's a period we're picking up of a pulse of energy from a bearing. I hope that's sort of useful. And don't forget, if you want to see the Book of Gold, the only one in existence, she'll be at the main tech show next week, and this will be Andrew's Cook's copy now. Thank you very much. When the first batch come in, I'll do some more videos of some more case studies, because we got most of the bearings which are in the book, and I hope you'll enjoy it. Take care and have a nice long weekend.